Okay, so in 4, 5, and 6 it says find the value of c that makes the expression into a perfect square. Then we want to write that expression as the square of a binomial. So if you recall, a binomial has two terms, so we'll just call them a and x. And if you're going to square a binomial, it looks like that. So they want you to figure out what c is so that you can rewrite the area of this newly formed square in that format. Alright, so we're simply going to take half of b, and then we're going to square that. So I'm going to get y squared minus 14y plus 49. And I'm going to go ahead and do the same thing. So we're going to take half of 17, and then we're going to square that. And since I know I'm going to get a decimal answer, I'm just going to leave this in fraction form. So 17 squared is 289, and 2 squared is 4. So I can rewrite this as s squared plus 17s plus 289 over 4. And then last but not least, we're going to do 24 over 2, square it. So we get 12 squared, which is 144. So I can rewrite this as z squared plus 24z plus 144. So what I have now, I have these trinomials. They all represent perfect squares, so you could arrange all of these into perfect squares. Right? So all I have to do is rewrite them in this format. Remember, these are areas. Areas for squares can be written as side squared. So if you were to factor this, you would get y minus 7 twice. You would get s plus 17 over 2. And you would get z plus 12. So whatever goes inside here, you can always just think it's b over 2. It's b over 2. It's b over 2. Whatever this number is, that's what goes in this parentheses, if you want to make it a shortcut. Alright, so 7 through 12, they want us to solve by completing the square. Alright, so what I'll do is I will take you through number 9. I will take you through number 10. And I'll take you through 11. That way you can try 7, 8, and 12 on your own. So the first things first, I want to go ahead and make sure I don't see any parentheses right now, so we're going to rewrite it like that. So I don't want to see any parentheses to start. And then if I want to complete the square, if I move this 3/4 over, I know 3/4 isn't going to do the trick, so I actually want to leave it there. I'm just going to leave myself a blank space. And if it helps, write 1y, and I'm going to find my c value. And then I have to add that to both sides. So if I do half of 1 and then square it, I get 1/4. So I'll add 1/4 to each side. And then this will factor into y plus 1/2 b over 2 squared. And this side actually becomes a nice pretty one. And then we're going to square root both sides. So I get positive or negative 1. So I have to consider both of them when I get my final answer, since I won't have a radical in it. So my first answer would be 1 plus 1/2, or excuse me, 1 minus 1/2, which is a half. My second answer could be negative 1 minus 1/2. So I have to consider both scenarios, and that would be negative 1.5. So my two answers to the equation are 1/2 and negative 1.5. Alright, number 10, right off the bat, I notice that all of these are divisible by 2. So I'm going to go ahead and do that. It's always going to make your life easier if you make the problem smaller. Now, right now, as it stands, half of 8 squared does not get me 3, so 3 is not making this into a square. It needs to leave. And I'll find my own value that makes this a square. Oops, that should be equals. So half of 8 is 4, and 4 squared is 16. And I can rewrite this as t plus 4 squared equals 19. Square root both sides. And I get positive negative root 19. All I have to do is subtract my 4, and I'm done. So t is positive negative root 19 minus 4. And I'll treat 11 just like I treated number 9. I'll go ahead and distribute. I do notice that 6 goes into all of these, so I'll go ahead and do this a while. Make those numbers a little bit smaller, a little bit easier to work with. Now I do want to point out, if I added this 4 over here, this would actually factor. So I actually could solve this by factoring. However, the directions on my paper say complete the square, so we'll go with that. So if I do half of 5, which is 5 over 2, and then square that and leave it in fraction form, I'm going to get 25 over 4. And so I'll have to add that on this side as well. Instead of writing minus 4, I'm going to write minus 16 fourths, since that's the same thing as 4, but now I can add my fractions. So this now becomes x plus 5 halves squared. And 25 minus 16 is 9. We'll square root both sides and get x plus 5 over 2 equals positive negative 3 halves. So I'm going to work a little bit into this space just because I'm out of room on my side. So either I'm going to have x equals negative 5 halves plus 3 halves, or I'm going to have x equaling negative 5 halves minus 3 halves. So you have to consider both scenarios. Scenario 1 is going to give me an answer of negative 1, and scenario 2 is going to get me negative 4. So my two answers to this problem are negative 1 and negative 4. Personally, if I was doing number 11, however I chose, I would have used factoring because it would have been much quicker. So in terms of speed, the square root method is always the fastest, and then factoring, and then completing the square. So if something factors, it's definitely going to be a lot easier to do that versus completing the square. So that would be my recommendation. However, again, if the directions specify that you have to use a certain method, that's the method you have to use. So at this point, I'd like you to pause the video and try 7, 8, and 12 on your own, and then I'll post the work and answers. Okay, so you can take a look and see how you did here. All right. Removing this negative 2 and the 28 because they're not going to make this into a square, and finding my own squares of 9, 25, and 9. And then obviously rewriting it so that I can apply the square root method. Okay, so in this next problem it says explain how this expression is a perfect square trinomial. Once you do that, write the expression as the square of a binomial. So rewrite it as something squared. So first off, I noticed that I have 4p plus 1 twice, and that could get a little busy to look at. So let's just call that something like a. If I do that, I can rewrite this polynomial as a squared plus 8a plus 16, and that's just a little bit easier for me to gauge perspective versus this big long thing. And I put it up here so I don't forget what a is actually equal to. So I haven't broken any rules. So the rule for being a square is that b over 2 squared should get you c. So if I run this into that formula, b is 8, c is 16, 8 over 2 squared does equal 16. So I would go ahead and say it's something along the lines of, it's a perfect square because the b and c values of 8 and 16 satisfy that formula. So then all I would have to do is remember, if you write x plus b over 2 squared, that is the rule for factoring this really quickly. So I'm going to change b into 8, and we're not using x, we're using a. But we have to remember a was actually equal to 4p plus 1. So I'm going to change that back, and also 8 over 2 is 4. Do a little condensing, and I get 4p plus 5 quantity squared. So in my next video, I'll go ahead and take you through these next couple problems.